Hi, uh, I'm Jerry Scripps, and you reached this because you're in my CIS 635 class. You've found your way to Blackboard, and you are watching the first of many videos that I'll post here for lectures on a weekly basis. Notice, first of all, that my intent was to have a video of me in the corner, but apparently the software that I'm using to record my voice is also grabbing the camera and freezing it, so you just get to see a picture of me with kind of a wide-eyed stare in it. Anyways, so this is the process that we'll be going through. I'll post lectures on a weekly basis, and then I'll also have homeworks for you, eventually a project, and exams also. We'll also have a weekly discussion. Okay, so because you don't get to ask questions, I'll have a discussion where I'll ask you questions, you give me answers, and I don't want you to be too concerned about those sessions. You can be as prepared. I would like you to be prepared for them so that you can answer the questions, read the materials ahead of time, and watch the lecture and everything. But if you have to answer "I don't know" or "I'm not sure" to questions, or you don't have something to add to the discussion, that's okay. But I would like your discussion to be part of the grade. So so the more you participate in there, if you participate for the amount basically allotted to you. If I have 6 people in the discussion, then I don't expect you to dominate the discussion or anything like that, but spend as much time as you would normally allot to 1 out of 6 people, right? Okay, so I just want to point out that I do this in my house, so you may hear dogs or people in the background ask me questions, that sort of thing. I'll try to keep those distractions to a minimum, but that may happen. The other thing that I wanted to point out is that this is since it's totally online, you don't have a chance to ask me questions for the lecture. So what I'd suggest that you do is maybe write stuff down as we're going along. Have have a notebook app up, or write it down on a piece of paper or something like that. And then when we have the discussions, then you can ask me those questions during the discussion time. Okay, so right now I'm going to get in and talk about the first week. And I didn't want that to take over the whole thing. Slideshow settings in a window. There we go. And that's what I wanted to do. All right, so start with, real briefly, how do we represent information or data or knowledge or whatever in when we're working on it. So there's 4 different levels. We'll talk about data is the basic level, and that's just numbers or characters or whatever stored in a file. Hopefully it has a little bit of a structure to it. And if it's just text, we call that unstructured data. But it doesn't really mean that much until you process it in some way. So I could tell you, I could give you 2 numbers like 27 and 30, and that doesn't really mean anything to you. But when I organize that and then put some other textual information, like let's say Detroit and Chicago, and say that that's the score of the basketball game between those 2 teams, then suddenly it becomes information. Then it's meaningful, right? So, so that's one step up from data. The next step up is now we take that information and we process it even further using some more complex statistical techniques and some computer processing, And then it gets to the point where we call it knowledge, and you can think about that as like rules, and using context and experience to try and explain things. It's a little harder to explain, but that's the next step up. Wisdom, we're not even going to get into that. Wisdom is something that not everybody agrees upon, so let's just skip right over that. Okay, data mining. My definition of data mining is that it's the search for hidden knowledge in large data sets. And so it doesn't make sense to search for hidden knowledge if I've got a data set that includes 5 employees or something like that. I mean, that's one of those things where you can just look at the data, become familiar with it, and then make your judgments based on that. But really, if you've got thousands and thousands of data objects, then it becomes more difficult for a human to scan over that information and drawing conclusions for that. But with a computer program, we can process it and group things according to different attributes, or we can calculate probabilities and do things, and then we can end up with something that's either predictive or something that's descriptive. A predictive result is something where we can predict weather, economics, customer purchases, some sort of decision support in the factory or something like that, which could include things like quality assurance, right? So which products do we keep, which ones do we throw out, and it can be based on some sort of data mining that we do there. Descriptive techniques give us an idea of what the data looks like or what we can expect from it. So having a big file of data may not be that helpful. Let's say a large quantity of demographic information about voters or something like that. But if we can break that down and discuss the characteristics of certain types of voters, as we'll see, we can cluster them and so forth. That tends to be very helpful to people at a high level making decisions. All right, so it's used for recommendations, things like, like suggesting a book to read. So there's a website called Goodreads that will analyze the books that you've read and the different, the books that of other people have read and how similar they are to you, or the same thing with Netflix or something like that. Make different recommendations. Web search. Web search is a difficult thing because some people can make their website look more authoritative by creating a bunch of small pages that all refer to that one website, right? And so in order to get around that sort of thing, they had to use some sort of tricks that they came up with about 20 years ago, which really improved how people search through the web, i.e. Google in this case. All right, theft and fraud detection. This is the sort of thing where your credit card might get like a particular transaction or something that gets flagged as possible fraud. All right, and so they let you know about that, and if it's something that you didn't do, then you can get them to take that off, and then they'll try to track down who's using it and get their money back that way. Supply chain optimization, so when manufacturers send products to distributors send those on to retailers onto you. That's the whole supply chain. In the past 25 to 30 years, a lot of innovative techniques have been used to make the supply chain more productive and more profitable. And data mining has been part of that too. Certainly marketing is a big area that it's used for. So people in marketing can use that to segment the market and to isolate or to identify certain types of customers and locations of customers in order to get their products to the right people. And then oftentimes there's this kind of like vague notion of trying to make some decisions or look for new opportunities with the data that an organization has. So a lot of times an organization will come to a data miner and just say, look, we've got all this data, can you tell us what we've got, or what some of that hidden knowledge is in there, so that we can maybe make use of this in other ways. So that can lead to all kinds of new and interesting things. Okay, so yeah, so computers used to be a whole lot bigger, more expensive, and less powerful. And so if you go back 60 years, 50 years ago, 60 years, let's say, at least 60 years ago, memory cost a lot. It was a nickel a bit. So you've got a computer, and your storage on that computer might be a terabyte, or it might be, let's say, 250 gigabytes or something like that. So that would be, that's billions and billions, maybe even trillions of bits. So if you multiply trillions of bits times a nickel, that would add up to a lot of money. I mean, you're talking about millions, billions of dollars for that computer you have. If you could, send it back in time to the 1960s. Well, the problem is you can't do that, because we found better ways of making the computers, making the components. So they've gotten smaller, they've gotten less expensive, and they've gotten more powerful. So we have the ability to do that, right? And we've also got the internet and the World Wide Web now. So there's a lot of data that's available out there, and people accumulate it, and then sometimes make it available. So and then companies themselves are like Amazon and Apple and so forth are collecting a lot of data based on their websites, based on their the commerce that they that they process or whatever. Okay, so there's a ton of data out there. It's being generated, and it's not really being analyzed. So to see this in a picture format, you can tell that in 2010 it looks like we've got a minuscule amount of data, and this was created back in 2015 or 16, I think it was. And this is what the projected growth was. I'm not sure if it really turned out that way, but as you can see, I don't entirely agree with this, because it looks like everything grew at the same rate. I think if I was to do this graph, I think the actual data, what it would look like is that social media grew much faster in the 2000 to 2015. And then from 2015 on, then IoT, or Internet of Things, the sensors and the devices, that's been growing at a greater rate since that time. But I mean, this kind of gives you a little bit of an idea. The VoIP is just voice over internet protocol, and that's just people who use the internet for their phone service. The enterprise data is just Amazon and Google and everybody who maintains their own data set of customers and that sort of thing. So as you can tell, it's growing very, very fast. The problem is we're not generating people fast enough to use it. Here's another example of it. So if you took all the enterprise data and put it into iPads, you could stack them up and create the Wall of China, only 3 times taller than that. Well, the interesting thing is when I do some back of the envelope type of calculations, just based on how many phones are out there, how many iPads, and how many computers that people have. So this, so when I look at that, it seems as though us as individuals have about as much storage capability as the enterprise. So, Amazon and Apple and Microsoft and so forth, they have large warehouses with lots of file servers, what they call, data farms or whatever. So they've got these large collections of data, but we're carrying around a lot of capability too, just on our own devices, right? So it's impressive, but it's not also not that scary either, because you'd expect that industry would have that much. Okay, so you have a lot of data. You've got IoT, which is collecting a lot of information on sensors and so forth. So we need experts in that area. And a few years ago, they were saying that people with expertise in NoSQL, that was going up at a rate of like 50% per year, and big data was going up about the same rate. And it doesn't seem to have slowed down that much. It seems as though industry is finding out the value of people with data science backgrounds, and they're continuing to make use of them. All right, so where does all this stuff come from? Just business operations. Every time you buy something, it goes in as a record, right? Okay, web pages generate, there's billions of web pages out there, and they contain information, but then people also use those things like in social media applications and so forth to put down every little meal that they have or every little thought that they have, that sort of thing, and that information is collected. Internet of Things are the sensors and stuff that, as you walk into a store, it records your visits. When you pump gas at a gas station, that stores the information of your transaction and so forth. Playing games and gamification of tasks. That's another way that they're able to collect information. So they want you in front of your computer, in front of your tablet or phone, doing things to generate more data for them to use. Also crowdsourcing. So crowdsourcing is not a new thing. I just wanted to point that out. So a lot of times, people put information in, like Waze. I don't know if you've ever heard of that. Where are you now? Waze. I don't know. There's applications where you can put in information about traveling on the on roads and stuff like that, and they use that information to try and recommend what routes people should take, and so that they can find out that people are slowing down on a particular route, so they route them around those. And there's other ways that they do crowdsourcing, right? But think about weather and the Oxford English Dictionary, OED. And weather, in the early part of the 20th century, they used to, a lot of times, you would see these weather vanes on farmers' lands as you go by there. And, that's something that's sort of helpful for farmers to have, see, the wind is blowing, or, where it's coming from, that sort of thing. While it's of minimal help for the farmers would also record that information and send it to what was to become the National Weather Association, or National, some sort of it's now Oceanic and something else. I can't remember. NAO, something like that. But that is collected now by sensors, by IoT. But in the early part of the 20th century, it was collected by hand, and they just sent that information in, and that was, you know, helpful for them for predicting weather or analyzing weather. And another thing that predated this is the Oxford English Dictionary, and this was created in the 1870s or 1880s or something way back then. So what they did is they just asked people to send in just slips of paper where they found a word. And then they organized this manually. They had no computers back then. And what they would do is for any particular word, they would find out where was it first seen, where was it referenced, and so forth. And that's how they created the Oxford English Dictionary. Is they would define these words based on the references where they were used. So another example of something that's been around for a long time. Okay, what's data mining? Looking up phone numbers, retrieving customers' information. That's just simple retrieval. Data mining is being able to tell that certain names are more prevalent in different locations, or grouping similar documents by a search engine. And there's a lot of other things, but we'll find that as we go along. These are kind of helpful, these Venn diagrams, to get a feel for it. People say, what are you learning? And you say data mining, and they say, what's that? And so it's sort of hard to tell. And a lot of people don't really understand the differences with artificial intelligence and one of the other things. So artificial intelligence is a big umbrella. So that contains a lot of different things. But a big part of artificial intelligence now is machine learning. So in the early days of AI, there were a bunch of different ideas that were battling for prominence in artificial intelligence. But learning systems really kind of took prominence pretty well. It was after about the time that the web was created, because we were having so much data generated that they were obviously used, you know, for learning from that data. Okay, and then within machine learning, you have representation learning and deep learning. That's not as important as just knowing that machine learning is part of AI. So the next slide tells us a little bit about the makeup of data mining itself. And really, I think the circles you want to see here are data mining, pattern recognition, and machine learning. Because in this picture, the way I've drawn this picture, it looks like they're slightly overlapping, but they really should be very much overlapping. There's a big overlap between pattern recognition and data mining, and between machine learning and the other two. Yeah, so I'll get back to that other one. I had to go ahead and make sure that I had that slide coming. I'll talk about the difference between data mining and machine learning. But artificial intelligence, right, contains the technique of the discipline of machine learning. Databases is a big part of data mining, because you have to get the data from somewhere, and then statistics plays a major role. Statistics plays a major role in machine learning as well. Unfortunately, this isn't a very good representation of this whole thing, but statistics should be part of data mining and machine learning, both. But yeah, take it for what it's worth. Just think of data mining. Really, data mining is a big part of AI, but then there's components of it that belong to statistics and databases. And as a matter of fact, our data mining here at Grand Valley is part of computer information systems. In other universities, it might be part of statistics. In other universities, it might be part of you know, another department. I mean, it's possible that it could be in management or something like that. So it just depends on which direction you take it. All right, so machine learning and data mining, what's the difference? Think of machine learning is like using pure math and statistics, and data mining is more like engineering, which is more of an applied type of thing. So we're taking the things that they do in machine learning and we're applying those to large data sets. Generally, that's a good way of looking at it, although when we're in data mining, like people like me in data mining, we certainly do a lot of work with coming up with new techniques too. So, you know, I guess you could say that maybe we switch hats and put on our machine learning hat or something. This shows you how data mining fits into the whole process. So if you're going from starting out with just some data and you want to go to having knowledge that you can make some sort of decisions with and that sort of thing, you have to go through this whole process. And this is the difficult part. I mean, going up to the data mining, that's the fun part. That's like, we get to this point and it's like riding a roller coaster or something. Whoa, boy, this is great, right? But you have to go through a lot of hard work to get to that point. So you've got some raw data and you want to clean it. Oftentimes there's missing records, there's discrepancies and other things. And so you date it, you do clean it and organize it and put it into a warehouse. And then once it's in the warehouse, then you can select out and transform it into a data set. We'll talk a little bit about transformation in chapter 2 or 3. And then this data set will, for this class, pretty much look like a rectangular or a tabular thing where you've got rows representing different objects and columns that represent the different attributes of those things. Once you get it down to this point, now you're in good shape. So then what you can do is you can do some data mining on it and then look at the patterns. Not done yet though, because you might look at these and it brings up other questions, and then you want to go back and do some more data mining or go back and get more information. You could get done with this and you look at these patterns and you go, wow, this is great, but wouldn't it be interesting if we could group this by region? And you go, well, we don't have the region. Okay, well, let's go back to the data warehouse, find the region, put it in there, and then include that as part of the data set. So it's this process of going round and round until you come up with something that you can present to management. Okay, what are the different tasks? So people group these things differently or discuss them differently. But generally, I think they agree upon the fact that you have classification, clustering, association rule discovery or association analysis, anomaly detection, and regression. So classification and regression are very similar. So I'll talk about classification first. The idea behind that is you take some data and then you have a certain number of finite classes. All right, so let's say I've got some data and my class is gender, male or female. All right, or I could have another class of succeed or fail. We're talking about how students do throughout a program, or accepted into the program or rejected from the program. Let's say we've got students who are trying to get into our data science program. And so what we're trying to do in classification is we're running analysis on the data, and then as a result, we want to be able to put in data where I don't know what the class is. Should we accept this person or should we reject them? Or maybe I've got political leanings, and it could be a three-class problem. We've got liberals, conservatives, and independents, those three. And so what I want to do is I want to look at, so I've been given information about people where I have the class. I know that they're a conservative, I know that they're a liberal. And so I use that to build a model, and then from that model I want to look at new instances where I don't know what their political leanings are, and I want the system to tell me, to predict what they're going to be. The next thing is clustering, and this is, well, I mean, think of what a cluster is. A cluster is a group of things, right? So we're taking a big data set with thousands, maybe millions of objects in it, and then we want to cluster these objects into groups. All right, and how does that help? Because then we can look at those groups and look at the attributes of those groups, and that tells us a little something about it. So I could take a bunch of voter information and cluster that and say, well, this one contains information about, this cluster are the 18 to 25-year-olds, and they're generally not college educated, and they work in the trades or something like that. You know, I mean, it just helps you to describe a group of people or a group of objects, and that gives you more information in order to, I don't know, maybe devise a marketing plan or you know, a political strategy or something. The next one is association analysis. And this is probably the oldest of all these things. Well, maybe regression is, I don't know, but this and regression are the granddaddies of these techniques. Some of these things have only been around for about 20 years, but association analysis has been around a little bit longer. It really started with the grocery stores. So the grocery stores started using electronic devices, cash registers, back in the 80s, and so as a part of that they collected information, and then companies took that information and found out that they could do some analysis on it, this association analysis, and they could look for some interesting patterns. So one pattern might be when people buy cereal, sometimes they also buy bananas to go with that, which is why you oftentimes see bananas hanging out in the cereal aisle. And you know, there's a lot of other rules like that they've seen, and this sort of helps that helps them in the marketing area try and maybe suggest things to customers. When somebody's ringing somebody up, it might say, well, a person that's buying these, you know, a person that's buying these products here might also need paper towels, and so it might generate a discount thing for paper towels in order to try and encourage that for the next visit the person makes. All right, the next one is anomaly detection, and this technique is looking for unusual transactions or unusual things. And we'll talk more about this in just a minute. We'll go over anomaly detection. We're not going to spend as much time on this one as we do the other ones. Regression, we're not going to spend any time on that because I'm assuming that you're going to see that in another class that you take. The statistics people cover that in one of their classes. I think it's 520-26. So, but regression analysis, think about classification. It's just like classification, only what you are predicting is not a class, but a number. All right, so maybe what you could do is predict how much money somebody makes, what their salary is. So we don't know what their salary is, but we build a model in order to predict it, and then that can actually use that model with an unseen, or with a person without knowing what their salary is, and then predict it from that. So another useful technique, but you're going to see that in something else. All right, so in more depth, I'll go through this kind of quickly. In classification, we start out with a collection of records. That's called a training set. In the 4th week, we'll start getting into classification, and then we'll define a little bit better what a training set is. All those records contain a set of attributes. Like if we're talking about people, an attribute might be age, salary, political leanings, gender, you know, anything that helps to describe that object or record. And then one of the attributes is the class, and that's a finite number of things. And so then what that will do is that'll create, what we'll do in classification is we'll create a model using the class attributes. And then when we have other records where we don't know what the class is, then using this model we'll be able to predict those things. Sometimes we're also given a test set, and what that is just like the training set, except for we're going to pretend that we don't know what the label or the class is, and then we'll predict it, and then we'll be able to compare what we predicted with what it actually is to see how accurate we've been. Okay, so this shows a real quick example of that. Here's our training set over here, where we've got the objects and then the class. Did they cheat on their taxes? No, no, no. Yes, this person did cheat, and so forth. Then over here we've got some unseen ones where we have all of their information for refund, marital status, and tax income, and then we don't know whether they cheated or not. So this test set is applied to the model, and then the model will tell us whether they cheated or not. All right, so typical application is like in direct marketing, where we want to reduce the cost of mailing by targeting a set. Now this is something that applied more to the 20th century more than this century. In this century, direct marketing is more like sending out spam emails and that sort of thing. Well, spam emails are costly too. You have to get the names. You have to, you get a certain amount of ill will by sending those things out to people who don't want them. So really, what people want to do is target market. So they get your name because you were on Google and you were searching for boats or something like that, and you're a boat dealer. So then Google sends those names on to you somehow, or you're able to get some data to find out if somebody is interested in these sorts of things. And so then you only send out those things to those people who are targeted by those. So that's one application. Another one is churn. What that means is customers buy from you for a certain amount of time, and then suddenly they find a better deal someplace else, and then they stop buying from you. That's what churn is, when people stop purchasing things from you. So it's very important to companies to try and figure out when that's going to happen. All right, and then clustering is, again, you're given some data like you're given, same kind of data that you're given for classification, except for you don't have a class. So just think of it as the same thing, but there's no class involved. And then so you can't predict anything because we don't have a class in order to make that prediction. So what we're going to do is we're just going to gather them into clusters. And then once you put those things into clusters, then you can look at the attributes of the clusters, look at the averages of the attributes of the clusters in order to try and make some sort of decisions based on that. All right, so this is a 3D illustration of that. If we had 3 attributes, you could have like salary going in this direction, age going to this direction, and experience going in this direction or something like that, then you can group these objects accordingly. Okay, examples of that: market segmentation. So use it to divide up the market into older customers, middle-aged customers with a high salary, customers with a lower salary, but but are interested in country music or something like that. Just breaking things up into different segments or different clusters. Document clustering. So you see this in Google all the time when it comes back and it says, okay, here's a news story and there's 20,000 other news stories like this one. So it just kind of groups all those things together and then just pulls out some one of the stories that kind of represents the rest of them. All right, so document clustering might look something like this, where you go out and find 3,200 articles from the Los Angeles Times, and then group them into financial, foreign, national, metro, sports, and entertainment. Association rule discovery or association analysis. Things look a little bit different. The data doesn't look like a spreadsheet where you've got rows and columns. Well, we could have rows and columns. We could have a row for bread, one for Coke, one for milk, one for diaper, one for beer, right? And then they just put a 1 or 0 in those things. But I mean, if you got a business like Myers, where you've got tens of thousands of items, I mean, it's sort of hard to and visualize it that way. So we tend to visualize it as just a list of items and then these transactions. So, you know, somebody might have up to 20, 30, 40 items in there, but that's it. They wouldn't, how many people walk into Myers and buy 10,000 items? I mean, I don't think that happens very often. Okay, and then what you try to do is, you know, predict some rules based on that. So, so when you see milk, you're also likely to see Coke. When you see diaper and milk, then you're likely to see beer. Yeah, those are the sorts of rules that you try to find in association analysis. Okay, so obviously used for marketing and sales. So. So when you see bagels and some other stuff, you see potato chips. Okay, so you can use this in order to try and boost the sales of the thing that's in the antecedent or the consequent, or inventory management. And so as repairs come in, you might be able to notice that when somebody has a repair to one part of their vehicle, they might also need to repair a different part of the vehicle too. Sometimes they do that based on, well, just getting into that part of the car, you might as well replace something else at the same time, right? But association analysis can definitely be used for that sort of thing. Okay, and then anomaly detection. This is like somebody stealing your credit card or your identity or something like that and making false charges on that, or network intrusion. So somebody has a DDoS attack or something like that on your network. How can you tell that an access is valid or invalid? Most of them are valid. That's what makes it hard, is because it's, if you have a two-class problem, normally you'd say, let's do classification for that. But that's usually if the two classes are somewhat equal, right? So if it's male and female, you've got equal numbers of both of those things, right? Or approve or reject or that sort of thing. But with network intrusion, there are far more valid accesses to the network data than there are invalid ones. So it's a hard thing to do, and it's it's vitally important that you're able to detect those invalid ones. Okay, regression, I'll just jump right over to that. Okay, so challenges. Scalability is one of the main ones. So a lot of these techniques work fine for 1,000 objects, 10,000 objects, but if you get up to 1 million objects or 1 billion objects or something like that, it might not be doable. It might be that it slows down to the point where if it takes a week to do the analysis, that's not soon enough. So we look for ways in order, that's the computer science part of it. So a lot of this stuff is, we've got our statistics hats on in order to maybe build some of the core component of the technique. But later, the engineer or the computer scientist in us needs to look at it and say, okay, this works great, but we need to try and scale it for higher numbers. How can we improve the speed? What can we do to it, right? So that's one challenge. Another challenge is dimensionality. And when you first get into data mining, I used to think anyways, I don't know if everybody is the same way, but look, if you give me as much data as you possibly can, I should be able to predict anything. I should be able to predict anything with 100% accuracy. All right, so I've got students coming in, and I have to try and predict whether they'll do well in our program or not, let's say. So there's all kinds of data that we could try to collect on it, especially if, if there weren't, laws against, we can't ask for your, for you to send in a blood sample or something like that, but, there's lots of data that we can imagine trying to get our hands on. The problem is as the dimensionality goes up, as the number of attributes goes up, the amount of data that we're collecting, the accuracy will sometimes start to go down. In other words, the algorithm gets confounded by the amount of data and is not able to make as good a decision, or as if we just generalized and have less data. So, so we have to consider that. And then what that means is sometimes we have too many attributes, and we have to try to do things in order to scale it down. And then the next one is data can be more complex. So this could be like if I have data that's not just in a tabular format, but it's also in a network. So if I get some data from Facebook or something like that, that's great. Now I've got a network graph of who's friends with who's. Okay, but data mining algorithms are not set up to make use of that data. So trying to come up with new algorithms to deal with that. Or the other thing is, what happens if we have sequential data, stock exchange that's coming in on a stock ticker. And it doesn't matter so much it matters, but what's the price of Apple Computer? Well, also, what's the price of Apple Computer yesterday and the day before and so forth, and how has it changed? And so that's another one. Data quality is another issue. Ownership and distribution are issues. These are issues that we're not necessarily going to get into. Privacy preservation, we're not going to get into that. It's something you should probably know about. Sometimes people make their data available. Sometimes somebody might make their data available to you, like if you're doing an internship or something like that, and they say, well, you're not really an employee here, so we're going to give you this data, but we're going to anonymize it, which means that they remove all of the identifying parts of it. Maybe they've got customers in there, and they take out the name and address and phone numbers and that sort of stuff, but they just give you the IDs and some other information. Okay. So I think that's it. And I'll also have the R video for you to watch too. So, and I'm going to have discussions. So I don't think I'll do that until the second week. So there'll be a homework that I'll have for this and the R things that you will see. And before that homework is due, I will we'll have the discussion so that you can ask me questions about that during discussion, or we can talk about other things as well. All right. Thank you, and end of recording.